I'm so excited. Almost every single time I open up my phone, I see the next nuclear progress and process in place. So today we're really going to be focusing on that. And one of the most common questions that people ask is really how can we improve the construction process? How can we improve the rollout process? So I want to hand it on over to you guys to discuss how can we accelerate this rollout of nuclear energy? Are the considerations technical, financial, operational? What are the biggest challenges? What are the biggest?
You want to start?
Yeah, sure. That is, Grace, and I face the same with you, excitement about what is happening right now in nuclear and overall on the energy sector. You asked the question, what is coming and what are the thresholds of developing these new plants. I believe that the technologies are ready, and it's not really a roadblock on the technology side. Thanks to the great work as companies are doing, collaborating together with ARPA-E, with national labs, we have de-risked a lot of those technologies. If I talk on the case of Westinghouse, the AP1000s are technologies that are up and running, are being built. There are 6 overall worldwide and 12 under construction, 2 in the United States. When you go into the SMR on the microreactor side, it is the same. Those technologies are coming very, very almost ready to scale up and being built. The supply chain is there because we don't utilize only supply chain for nuclear, but for all the projects that are happening in other sectors. But there is one piece of the puzzle that is actually missing, is the financing actually right now. How actually we can innovate on the business side as well, so some of those projects actually can see through. It is critical for firm capacity, and it's not only nuclear. If you talk with other technology providers working in geothermal, for instance, they are all facing the same things because these kind of firms technologies, they need capex investment at the beginning of the program that are considering important. So that's why you need to find out the right combination. That is really my read, but I really believe that on the technology side, it's very, very exciting what is happening at the technology brick level and also at the product level.
Yeah, great. And so thanks for having me. Folks, I'm John Kotek with the Nuclear Energy Institute. We're the trade association for the nuclear technologies industry here in the U.S. So we represent the operators of the plants, but also the technology suppliers, fuel companies, national labs, universities, a wide range of folks active in the sector. So we try to take a big picture view of what's that the technology is ready. There are more technologies coming. In terms of what it's going to take to get to new deployment here in the U.S., I think job one is keep running the plants that we have and keep running them at world-class levels of performance and safety, which we do here in the U.S. There have been very important policies passed, including supportive tax policies enacted in the last couple of years that are important to retain if we're going to make sure that those plants stay viable. And then the same thing goes with new wind and solar, for example. Retaining those financial supports are going to be really important, as is going to be retaining things like the DOE Loan Programs Office to enable to get the financing right, because so much of this is about addressing what we call the early of a kind additional cost and then additional risk that comes from building a capital intensive, large new technology like a nuclear power plant. We already saw with things like the around the world are running super as well. The first one cost more. The second one at that same site there at the Vogtle site cost about 20% less. And we're going to see new deployments move down the cost curve as we get to a sustained program of new build and a stable regulatory environment. So if we can get that financing right, help the first few get sort of over the hump, I think we're going to see a lot more new nuclear built here in the U.S.
All right, so I've heard both of you mention AI going to play in this? What role is this massive technology boom going to be playing in nuclear expansion?
So we are facing an incredible moment, and I think the secretary mentioned it as well, because AI is helping us in two ways. It's helping us because it's creating a demand. If we read the different reports from OCDE, even from NEI, from AI, just make a new outlook, the increased use of AI is requiring an increased demand. And in the OECD countries, we've never seen that in the previous decade, and now we are seeing actually that demand increase. But AI is also helping us to deliver better because we are utilizing nuclear-specific AIs, like in the case of Westinghouse, to deliver better design, construction. One of the things that is incredible in nuclear in our industry is that because of the regulatory frameworks that we have, we are data-driven people. We track everything, and we have data from 65 years of operations designing that is waiting there for being utilized in a way that it's going to help us to design better, license better. And right now we are starting to see also those benefits. So it's really both what AI is doing, introducing new business models, because right now, I mean, in the traditional way for big CapEx investment programs, and it's the same for all CapEx investment programs, usually you have, okay, a vendor or role was to design, to license, and then find a utility that said, I need that capability. And then the utility will choose an EPC and take the risk of the program for a number of years. Why they were doing that? Because when you calculate the LCOE through, and right now in the United States, we're going to have plants that they are going to be up and running for 80 years. So the cost of the electricity of those plants, all those assets are already amortized. So it's incredibly interesting for them to move on that area. But right now, to build new ones, how I take those first 15 to 20 years where I don't have yet my return to investment, and we are getting some of those hyperscalers. And I think most of you has been reading in the media the amazing CERAWeek that happened just last week, where a lot of those companies really, they say we need to triple actually those capabilities, because we are talking here about gigawatts that needs to be built. And that puts on the equation another actor that we need to find how together we find that business model that makes the utilities, us, the vendors, as well as the hyperscalers feel comfortable. And for that, we need also the government, as John was mentioning, in a private-public partnership, where some of those risks are actually shared equally and in a fair way. And that shifted the model where actually the utility was taking the risk and the vendor during all those decades of development and licensing.
Yeah. Just to draw on one example, actually with your company, Constellation, right? We've seen this public-private partnership really work with the restart of what's now going to be called the Crane Clean Energy Center, right? Formerly the 3 Mile Island plant, where sure, you've got the company working with Microsoft and Microsoft's willingness to pay, premium for that firm clean power that's going to come from that plant. But the federal tax credit, the financing right to get to that new project. And as we look at new build, a lot of this demand that we're looking at trying to fill with new construction by AI. It's also being driven by increased electrification, whether it's building, heating, manufacturing, you name it. And I do think that does introduce more opportunities for some of the end users to participate in addressing some of the cost hurdles for themselves, folks involved in the construction, the potential off-takers, the utilities themselves, all playing a role in holding a share of this added risk that comes from going first. We're also seeing states willing to step up. And in fact, just this week I'll be traveling down to Texas to testify on a bill that they've introduced that could lead to a $2 billion fund for, to support new nuclear construction. So today, I think there's going to need to be a federal role as well. If we can get get the first handful of these projects underway, I think that's going to unleash just a whole wave, really a second large wave of nuclear construction here in the U.S. And I haven't even touched on international, but the international market's potentially huge.
Yeah, and just to reiterate, just in case you didn't hear it because of the mic, that bill in Texas is $2 billion with a B dollars in support of expanding new nuclear. Which I think is really incredible. And I have to say, you brought up data restoration and like the data that we have. As somebody who's in the beginning of my career and has filled many data requests, I can promise you we have data for everything. I have seen so much from the 60s to from yesterday. It's wonderful. So if you have any questions, I'm happy to supply that firsthand experience. But one thing is moving into this forward-looking mindset and what emerging transformative technologies that we're going to be seeing that could be substantially enabling in this rapid deployment of new nuclear. What should we be looking out for?
So for me, there are two trends. Obviously, I like to call them technology bricks, that they are the initial units that actually allow you then to grow up and build products and services. I think what is very interesting about programs like the ARPA-E and other DOE funding is that when we work at the technology collaboration needs to be incentivized and promoted, because otherwise we cannot reach out those roadblocks. So we have identified in Westinghouse kind of 15 technology bricks that we believe they're going to have an impact in the short term, but also in the long term. But I would like to focus in two trends. One, obviously, is the AI. Why? Because the AI is impacting how we're doing research, how we're doing innovation, how we are operating, how we are licensing. So we system that we have developed in Westinghouse, we call it Bertha, in honor of Bertha Lomers, that was the first mechanical engineer in the United States and the first engineer female in Westinghouse from the 80s. So it's as Bertha, it's because we have all that data in our industry that we can utilize it, but it's really impacting a lot in a very positive way and accelerating the designs. So that is one trend. The other trend is materials. I think material science, especially in nuclear, I think something that has brought the SMRs and Generation 4 and fusion is bringing the possibility to do R&D again in different materials that are going to have a huge impact in how we build, but also how we construct. Because if we are thinking about modular construction, I'm sure people in the audience, they don't know, but the AP1000, one of the learnings, and thank you, John, for pointing the learning curve from Vogel 3 to Vogel 4, is actually the modular and mechanical. Why we can do that? We can do that because of digital, because we have a full way of designing that goes from one way to another on the chain of development. What we are seeing right now with materials is that there is a mix, and all those technology bricks are interconnected through AI, where AI introduce also in the material science new opportunities. When we are talking about additive manufacturing, additive construction, right now we are testing 3D concrete. To achieve the cost certainty that the market is requiring, we need to move there. So I'm super excited about the combination between data, AI, digital, and material science.
And just to build on that last comment, you look back at history, for example, the construction of the ABWR in Japan, when they were nearing the end of the latest wave of construction that they engaged in, they just over 3 years. What they found at the time was if they had the type of prefab concrete construction that Lou's talked about here, you could be looking at something less than 2 years, right? Could make a huge difference in terms of delivery of new nuclear power plants. And so that sort of thing has me really excited. Additive in advanced manufacturing has me really excited. As a former Argonne National Lab West person, I'm fast reactors in the fuel cycle. that could be deployed alongside those technologies, and work that ARPA-E has done at the back end of the fuel cycle, I think has really helped inform the possibilities and the potential at the back end of the fuel cycle. So really excited to see that. And then one other thing that I'm going to be really interested to follow in the coming years, and we haven't touched on this much yet, is nuclear for process heat applications. And you look at companies like X Energy working with Dow and the electricity, but for heat generation, there are going to be some integration questions that exist there. And I know, my friends at the Idaho National Lab and other labs are working on those sorts of things now. But I think, that's an area that's really ripe for more innovation and invention, because nuclear has a role to play beyond the electric grid in helping to meet clean, reliable, resilient energy needs economy-wide.
And yeah, that is where materials came into it.
Hear, hear.
Because in our industry and in general in the energy sector. And that is very, very exciting to see those demands that help us actually to build those R&D and innovation programs.
Okay, so you talk about materials, we're talking about the fuel cycle and things like that. So what can we look for in terms of specific fuel innovation? Is that something that can be implemented in our existing fleet? Is it only going to be for future reactors? How can research in those fuel processes be improved upon, and what role can that fuel play?
Impacting by those two things. AI materials are allowing actually to develop fuels for the current technologies that we have, from PWRs, BWRs, BBRs, that are incredible. We are seeing the first ATF, axial and tolerance fuels going there. We are moving into enriching higher so we can have better operability of those fuels and at the same time better safety margins. We are starting to see additive manufacturing. What we are doing is making a safer fuel with safer margins that stay longer in the reactor, so that is better for the utility. And at the same time, we're reducing the timings where we are constructing. So that is going on already for current fuels, and all the plants that they are currently up and running, they are benefit already for those technology bricks and those innovations. In parallel, we are seeing new fuels, I think, on the SMR sector. You mentioned X Energy. We can go and talk to my colleagues. They will tell you all about TRISO fuel. Why TRISO fuel is so interesting? Well, if you go to Google it a bit, it's always described like the robust fuel ever built, and it's creating new ways of thinking about the role of fuel on the safety case of nuclear that has an incredible impact as well on the licensing process, but also on the constructability, and at the end of the day, on the cost and the certainty of delivering those. Why? Because we are seeing with those that shift a bit how we have been thinking about nuclear, and that is coming through the fuels as well. And then more in the long term, we are also doing NU, and there are many different programs that we collaborate at. Really here, I would like to highlight the great work that national labs they are doing, because we couldn't start those programs without the support of our national labs and the testing capabilities that they have for all of us in the industry, with the support of ARPA. Now with the arrival, especially on the AI, on the research, it's the acceleration. When I started to work in nuclear, people usually focus a lot on the design of the reactor, but actually when you see the critical path of a new design is the fuels. On the operational side, is the same. What really counts on your LCOE at the end is also that part of it. And at the end, traditionally, is literally around 25 years of development. What we are seeing right now with TRISO, what we are seeing with LAU+, what we are seeing with the research process, we are downsizing that, integrating much earlier the regulator, making pre-topical reports, engaging them in a very early stage on the design, on the R&D, is helping tremendously to reduce that. And we need to do it to maximum 10 years, otherwise, because we will not be able to get on time to the projects that are needed in the United States, but also around the world.
And Lou gave such a great TF concepts, the ones you're working on and some of the others, provide the opportunity to potentially move from 18-month to 24-month fuel cycles in some reactors. So you could see some real increases in efficiency, in output that come from these designs. And then I thought your answer on the TRISO fuel was exactly right. It's such an exciting thing to see. And just as a reminder for folks who may not be that familiar with it, DOE and the National Labs played a huge role in companies like whether it's X Energy or Kairos or any number of others are taking advantage of that great work that came out of DOE and the National Lab System.
And just to define ATF fuel, are we all well-versed in our nuclear acronyms here by now? Sometimes yes, sometimes no. ATF is accident-tolerant fuel, just for a little bit of background there. And it's really amazing because there is that work going on in existing fuel processes. How can we improve that? But then also these completely new types of fuel as well, which I just think is so chain. What is going to be the biggest challenges here? Are there manufacturing bottlenecks? Looking at the processing, the specialized materials, all this manufacturing that can impact the deployment. How can these specific bottlenecks be addressed?
So I can start as we've been discussing. I mean, the fact that a company as Westinghouse has been building in the United States, obviously we cannot do that without a very, very strong supply chain. So we go in through these innovation programs to do it. So, but we don't, sometimes in nuclear, we have that tendency to focus too much on the nuclear industry, but when we work at the technology brick level, what is happening on the energy sector in general, on that supply chain is super interesting to us as well. So I think there is a supply chain that it is ready, but we need to grow it up. They need to see the certainty of the market. That at least is what we are hearing from our supply chain. We up to the market, but we need to be sure that the contracts are signed up. Because obviously when you are a supplier of RAN 3, 4, 5, you don't have the same investment means that a larger utility. So they are looking for those contracts to start hiring and to start developing it. The modular construction, I mean, what we have learned on the AP1000 and a lot of the SMR vendors, and obviously we introduced that as well on the AP300, on the Vinci, but also others that they know corridor, they say, how especially from Vogtle 3 to Vogtle 4, how we can do that, because it's one of the difficulties when you move from R&D into actually commercialization. The second point is the modularity of the construction, change a bit the shift. It means that what we have learned is that when you have structural models being assembly on site, so it's what we call off-site construction, it means that the jobs, they are not created on the site, they are created actually on the manufacturing. More long-term, they have a longer visibility in how those programs are gonna look like. So those are learnings that we are willing to share with the rest, of course, of the community, and we participate in different programs, including on NEA, to share them, because really a lot of people knock us over with those two areas. How to build a strong supply chain, how we can actually build modular and construct modular. And it's not that simple. I have spent 10 years of my career on the automotive industry. And it's gonna build there and the shipped it is done. It's a bit more complex than that, because the modularity, you need to integrate it from the design itself. So, and that is again where the digitalization came and the AI came into it, because the full package of digital from the design until actually you give back the program to the operator needs to take into account those areas. And that's why right now it's so exciting, because those technologies are ready.
of course, every design is going to need something a little different, right? And the supply chain's going to be different. And maybe for the AP1000, you've got some very large components that we can't necessarily manufacture in the U.S. today. How do we ensure that the manufacturers of those either get established here, or in any case that there's enough of an order book that they, to Lou's point, that they feel confident making the investments needed to be able to produce those components at scale. Other things like some of the graphite reactors. Some of the smaller technologies, maybe they can manufacture in facilities in the U.S. that maybe can't handle some of the big components. So it's going to be very much a design by design, company by company issue. But there are some areas that we're going to need to ramp up. One thing we know that all the reactors are going to need is fuel, right? And currently we don't have enough capacity in the U.S. to convert or enrich fuels, both for today's reactors and for the next generation of reactors. Put it in a reactor, you have to enrich it in the isotope uranium-235. So first you convert it to a gas, then you enrich it, and then turn it back into a solid to make nuclear fuel. That conversion and enrichment step, we've got capacity in the U.S., but not enough to meet all of our needs, particularly as we start embarking on a new wave of nuclear construction. Fortunately, the Congress provided north of $3 billion to incentivize the availability of out of the Forrestal building and into the marketplace to help spur the development of that capacity. But the funding's been appropriated, so excited to see that move forward. And I think the key point is really what Lou said. You get to an order book, you build confidence in the supply chain. Frankly, that's going to bring workforce in too. That's the sort of thing we're going to need to ensure that our supply chain gaps are filled.
Yeah, and you just touched on something that's a very big part of this supply chain too, is the workforce shortage. It's not just nuclear, it's not just energy as a whole, it's everybody, it feels like. So what workforce development initiatives are needed to ensure that we have the skilled labor necessary to support this fleet-wide deployment and continue supporting our existing fleet as well?
Yeah, well, I can certainly talk about something that we're doing on behalf of the industry as a whole. At NEI, we've launched something called Nuclear Works. So check out nuclearworks.org if you're interested to learn more about professions in the nuclear field. We've people a sense of what it can mean to work in nuclear, but then also links to specific companies, Westinghouse and others, where you can go to start your nuclear career. So encourage folks to check that out.
What I think is very important as well is that our industry doesn't need only nuclear engineers. It is everything. I mean, I'm not a nuclear engineer for those that they believe I am. And the industry took me, trained me, and really built the new technologies that we are seeing, like AI on materials. We need all those kind of expertises, but we also need them on the business side, on the HR side, how you develop that, how we are thinking about knowledge management and transfer all that data, Grace, that is existing. And I'm sure during your daily work, you have all these reports to writing and all that, how we actually utilize that to really become nuclear. Because a knowledge or organization, I mean, if we start thinking in FTE, it doesn't work. We need to introduce this new way of thinking, and for that we need also people on the workforce that they are coming from other disciplines that can help us to build those knowledge and that knowledge transfer in a different way.
One thing that we didn't necessarily address too is like the role that young people are playing in this discussion around nuclear. I make like pro-nuclear social media content, and I get to spend a ton of time working with kids in schools. And it's amazing how often you hear it's safe to say 10 years ago, that was not the normal response. So in that capacity, even on the radio, I was just in Chicago and there was a violinist on the radio and somehow he ended up talking about nuclear energy. He was brought on because he's a child prodigy in music, but then he talked about nuclear. So it's really amazing to see the the day-to-day discussion that we're starting to have between people on a daily basis now, which is incredible. Now, we only have a few minutes left, so I want to leave you both with for you. What do we need today to get nuclear expansion tomorrow?
So I will say it in 4 words. For me, nuclear is an industry that we need to put it on the 21st century, and as you mentioned, making it cool, because it is incredible cool. For those that don't know it, really come and visit us. The first is that a future where we give sense. The Secretary said this morning as well, we have a huge impact, all of us working in energy, to impact and improve people's part of that future. The second side is how we are innovating, like doing rapid prototyping, utilizing technologies that we have seen in other industries, and now they are coming into nuclear. The third is really solving the pain points on the whole industry as a whole, to be sure that we can actually deliver in those gigawatts that are needed, or the heat that is needed. And the last point for me is really the data. If we don't start utilizing the massive amount, we will miss up the opportunity actually to have that sense and to impact our societies.
What I'd say is, first of all, in response to your comment about advocacy and enthusiasm for nuclear, all-time high, really great to see. I encourage folks to check out nuclearmatters.com as one way of getting involved in the conversation that you've been such an important part of. In terms of the future for the industry, what I see is a new generation. We are benefiting from plants that were built 30, 40, 50 years ago that now provide firm, clean power at an extraordinarily affordable rate. That was really a gift from our parents and grandparents to us. We need to do the same thing for our kids and grandkids, and that means building more nuclear. That's going to lead the way to more nuclear construction abroad. Companies like Westinghouse and others in the U.S. have world-leading technology. If we can get a new program of construction here in the U.S., that's going to pave the way for us to
So what we're really seeing here as challenges is this manufacturing and the financial portion of it, right? We've had so many amazing ideas discussed in terms of how do we tackle that? How do we move forward? So with that, I hope you all enjoyed and took a lesson learned about nuclear out of this, even if it was just you learned what an ATF fuel assembly is, all right? I will be quizzing you all on that, all right? No pressure. But truly, thank you so much for taking the time to listen to us today. Enjoy the rest of the day.
Thanks, everyone.
Thank you.